Nomenclature of BiCyclo compounds. BiCyclo compounds have two rings having two carbon atoms in common. So, more examples of BiCyclo compounds are this is also a BiCyclo compound because there are two rings in this compound having two carbon atoms in common. IUPAC rules for BiCyclo compounds are a little different than others. So let's solve these examples and learn how to apply this general formula in the case of BiCyclo compound. So for BiCyclo compounds, the first and the most important thing is numbering the chain. So numbering is done in such a way that the common carbons, one of the carbon is given number 1, and again the same rules will apply to the fact which carbon should get number 1 according to the first locant, sum rule and alphabetical order rule. And in this example, as the compound is symmetrical, we can give either carbon as number 1. So I give this carbon as number 1. Then there are two paths to reach this carbon. One is this longest path, one is this short path, and this is the shortcut. So numbering is proceeded in the way to the longest path. So as we can see that this is the longest path via hexane structure. The second number will be given to this carbon, N6. Then once you've reached this position by longest path, then the next number after this carbon is given to the carbon through the short path. And if there would have been a carbon over here also, we will not take that carbon. We will take the carbon which is via the short path. So there are three paths, you should remember it. One is the longest one, the other way is the short one, and the last one is the shortest one. So while numbering the BiCyclo compound, your preference will be to take the chain number, like giving the lowest locant to the longest chain carbons, then to the short ones, and then to the shortest one. So in this example, there is no carbon in the shortest journey. There are two carbons in the short journey. So the numbering will be done like this, 7 and 8. So this is the correct numbering for this compound. Let's do the numbering for this compound also. This compound is also symmetrical, so I can give number 1 to any of these carbon which are common. I'll number this carbon as my first carbon. Then see, there are three ways in this example also to reach this carbon atom. So this is the longer one. These two paths are identical. So you can say like this is longest and this is short and this is shortest. So it's up to you because the compound is symmetrical, so it won't make any difference. So I'll number this as 2, then this as 3, and then the carbon as 4. Now I won't take this carbon as my fifth carbon because once the longest chain is being numbered, I should number the short chain. So I'll number over here 5 and 6, and then we need to give preference to the shortest chain. So then I'll number 7 over here. Then next for this example, let's learn what these XYZ are. So for our first example, the XYZ will be, I will write like BiCyclo. Okay, now see what's our XYZ in these cases. So X represents the carbon in our longest chain. So there are, as you can see, in our longest chain, there are 4 carbon atoms, 1, 2, 3 and 4. So and in this example, there are 2 carbon atoms in our longest chain. So X represents the number of carbon atoms in the longest chain. So in the first example, the number of carbon atoms in the longest chain are 4. So our X will be 4. And similarly for this example, there are 2 carbon atoms in your longest chain. So your X will be 2. Now let's come to Y. So for Y represents the number of carbon atoms in the short path. So there are 2 carbon atoms in our short path. So your Y will be 2 over here, and for this example also there are 2 carbon atoms in your short path. So 2 will be written over here. Y is 2. And Z represents number of carbon atoms in your shortest path. So in the first example there is 0 carbon atoms in our shortest path. So Z over here is 0. And in this example there is 1 carbon atom in your shortest path. So your Z is 1 over here. So this is how you represent this BiCyclo part of your general formula. So this is very important to learn that what are your X, Y, Z exactly. So now in these two examples, if we see carefully, there are no substituents present. So there is no prefix. There are no functional groups and double bonds present. So there are no primary and secondary suffix. Now the only thing that we need to discuss is word root to name these two compounds. So word root represents the number of carbon atoms present in the chain. I'll write this. Total number of carbon atoms in the compound. Bicyclic ring. Okay, so in the first ring, in the first bicyclic ring, there are total 8 carbon atoms present. So the name for this compound will be like, let's take this only as general formula. So there is no prefix over here. Only after BiCyclo we need to write the word root. So the word root will be octane because there are 8 number of carbon atoms present. And there are no primary and secondary suffix. So this is the correct IUPAC name for this compound. This is the correct IUPAC name for this compound. And if I talk about this compound now, the word root will be heptane because there are 7 carbon atoms present in bicyclic ring. So the correct IUPAC name for this compound is BiCyclo 2.2.1 heptane. Let's solve one more example. So in this example, these are our 2 common carbon present in both the rings, and this is the longest path, this is the shorter one, and this is the shortest one. So numbering will be done like this: 1, 2, 3, 4, 5, 6 and 7. So the word root will be heptane because there are 7 carbon atoms present overall. No primary and secondary suffix because there is no double triple bond or functional group, and no prefix also because there are no substituents present. Now only part left is this bicyclo XYZ. So bicyclo. So X is the carbon atoms, as we've learned, the X is the carbon atoms present in a longest chain. So there are 3 carbon atoms present. So X's are 3. Then in the shorter path, there are 2 carbon atoms present. So Y is 2. And there are 0 carbon atoms present in the shortest path. So Z is 0. So this is the correct IUPAC name for this compound.